Hello, welcome to my channel. We have been solving this past exam. So right now I have this May June 2025. I'm sorry, 41 in front of me. It is mathematics or mechanics. So we already solved the first three questions in the last video. So now I will do question number 4. Okay, so this is question number 4. Okay. A lorry of mass 18,000 kilograms is traveling along a straight road. On a horizontal section of the road, the power of the lorry's engine is constant. There is a constant resistance to motion of 1600 Newton. The steady speed which the lorry can maintain with the engine working at power P watts is 30 meter per second. Find the value of P. Okay, interesting. So we have a horizontal section of a road and a lorry is traveling on it. There's a resistance force of 1600 Newton on it. The power generated in the lorry is P watts. Okay. Uh, the speed of the lorry is 30 meter per second. And it is constant speed. Steady speed because it's constant speed. Okay, so if I see the free body diagram, so the force working on this, remember we talked about it before that work is force into distance. If I divide it by time, work divided by time become power, and this is equal to force, and distance divided by time is speed. So from here you can see that the force is equal to power divided by speed. That gives you the force. Okay, so the force of the engine is P watts divided by its speed, okay, minus the resistance, which is 1600 Newton. Okay, so this is the net force working on the lorry. So this is equal to mass time acceleration. Now, if I apply this equation on the current situation, power is P, we do not know it exactly, and V is given as 30 minus 1600 equals, now there's no acceleration, remember, this going with a steady speed. So this part is 0. Okay, from here you can see that power is equal to 1600 times 30. Okay, and this comes out to be 48 kilowatt. Check the solution. Yes, so this is 48 kilowatt, 48,000 watts, which is 48 kilowatt. Okay, so this was very easy. Now let's move to part second part of this question. At an instant when the speed of the lorry is 16 meter per second, its engine is working at a power of this much. Find the acceleration of the lorry. Okay, I will use the same equation again, that the power divided by speed minus 1600 is equal to ma. Okay, so the power at this time is 40 kilowatt, so 40,000 watts divided by the speed at this moment is 16 meter per second, right? Okay, minus 1600, and this is equal to mass time acceleration. Mass of the lorry is 18,000 times acceleration. So we can rearrange this equation, find the value of A. You can see that A would be equal to 1 over 18,000 and 40,000 divided by 16 minus 16,000. So 1600. Okay. And this all came down to the 0.05 meter per second squared. Okay. So I hope these are very easy questions. You can understand them very well. Okay, part B. When the lorry has reached a speed of 20 meters per second, it begins to ascend a section of road inclined at an angle alpha. Okay, so it was going straight, and then suddenly it has an inclined surface. So this is alpha angle, and at this point when it started this slope, its speed was 20 meters per second. Okay. Okay. Mm. The engine now works at a power of 120 kilowatt. There's no change in the lorry's speed as it ascends the hill, so there's no acceleration. The constant resistance of motion is again 1600. Okay, find the value of alpha. If I talk about this free body diagram, the force of the engine is again okay. Power divided by speed, it will give you the force of the engine. Minus 1600 is the resistance, friction, whatever. Minus, now there's an additional force, additional factor here, which was not in this equation here. And that factor is mg sine of alpha. Okay, this is uh, the amount of pull you can say because of the weight and because of this angle, right? So the and this whole thing is equal to ma. Okay. So the power right now is given as 120 kilowatt. So 120,000 over the speed at this time is 20 meter per second. Okay. Okay. And yes, minus 1600 and minus MA, but MA is zero, right? So minus MA, let's write it MA, but this is zero. And this is equal to mg sine of alpha. Okay, so you can see that sine of alpha is equal to 1 over mg. Now m is 18,000. So 18,000 into g is 10. Okay. Uh, and here I have 120,000 over 20 and minus 1600. And this all comes down to be 11 over 450. And when I did inverse sine, so alpha is equal to sine inverse 11 over 450. And that comes out to be 1.4 degree. 1.4 degree. Okay. So I hope this question was quite straightforward. I hope you understand the logic we are using to solve it. Okay, now question number 5. Okay, this is about momentum, yes. Yeah, when the particle P of mass m kilogram has a speed u meter per second, its momentum is 4 Newton second, its kinetic energy is 16 joule. Okay, find the value of mass and its speed. Okay, so the momentum is given by mass into speed, and this is given as 4. And kinetic energy is equal to half m and speed square, so which is u square, and this is equal to 16. Okay, so from here you can see that m into u square is equal to 2 times 16 is 32. Okay, so now we have two expressions. We need to find the two unknowns. Let's divide this equation by this equation. So it is mu square divided by mu is equal to 32 divided by 4, right? So m cancel and we have u only, u equal 32 over 4. So this is 8 meter per second. Easy. And from the first expression, mu is equal to 4. So, sorry, u and 4 are very similar to each other. So m is equal to 4 divided by u, and 4 divided by u is 8. So it is 0.5 kilogram. Very, very easy question. Okay, now the next B part is a little bit challenging. It says the P, okay, remember there is P, which is, it is P, which is 0.5 kilogram. P is now projected on a smooth horizontal surface with a speed. Okay, now its speed is V. And there is another object whose name is Q, and its mass is 1.25 kilogram. Okay, I didn't write it properly, but I hope you can see. Okay, so speed was 0. Okay, after the collision, the speed of P, uh, after being collided, the velocity of P is W. So now its speed is W, and the speed of Q is 2W. Okay, so the loss of kinetic energy is 25 joules. We need to find V and W. So the initial speed of this P object and the final speed of both of them. Okay, so we know that the momentum is conserved. So what's the initial momentum before the collision? It was 0.5 into V plus 0 for Q, right? So this is the initial momentum of the system. So this must be equal to the final momentum of the system. Finally, this P has a mass of 0.5 kilogram and its speed is W, plus for this the mass is 1.25 kilogram and its speed is 2W. Okay, so let me simplify this thing a little bit. So it is 0.5 B is equal to 1.25 times 2 is 2.5, 2.5 plus 0.5 is 3, right? So this is 3W. And if I multiply by 2, it will be simplified a little bit further. V is equal to 6W. Okay, this is one equation. Now, second equation I will make based on the kinetic energy. So total kinetic energy of the system before the collision, it is half mv squared. So half mass is 0.5 and its speed was v. So half mv squared plus 0. 0 the kinetic energy of this one. Okay, now the energy loss was 25 joule. So I have to subtract minus 25 joule from here. So this is equal to the total energy of the system after the collision. And that is 1 by 2 m half m and v squared, and I mean the speed square, velocity square, that is w squared plus half and 1.25 and 2w squared. Okay, I hope you agree with all this equation. So let's simplify it a little bit. First of all, I multiply by 2 throughout. So it will cancel this half from everywhere. So this is 0.5 v square minus 2 times 25 is 50 equals 0.5 w square plus, okay, 2 square is 4. 4 times 1.25 is going to be 5. Am I right? Yes. So this is 5 and W square. Okay. I hope I'm doing it correct. Now let's get rid of this point 0.5 as well. So I divide everything by 0.5 or multiply by 2. So this will become V square minus 100 equal. Now this is going to be 5.5 W square. Okay. And when I multiply by 2, it will become 11 W square. Okay. So now I have two equations. One is this one. One is this one. I have two equations and two unknowns. So I can use them together to solve these two equations. So let's replace V by 6W. So V square is going to be 36W square. Am I right? Minus 100 equals 11W square. So 36W square minus 11W square. This would be equal to 100. 36 minus 11 is 25W square is equal to 100. So W square is equal to 4 and W is equal to 2. Easy. And from here I can find the value of V. V is equal to 6W. So 6 times W is 2. So this is 12. Okay. So 12 meter per second. And this was 2 meter per second. Okay, so I just solved two problems. I think this is the end of the problem. The next one. Okay, so yeah, we solved the two problems. Okay, I hope you enjoyed this thing. If you ever have any questions, you can always ask me in the comment section. If you get benefit from these videos, then I will request you to subscribe my channel as well. That will benefit me as well. Thank you very much for watching. See you in the next video.